All right, so this is going to be for all the views here. You guys ready? All right, so class. Oh, okay. I don't know if you guys could hear it, online, but that was probably one of my best for this class. Anyway, all right, finding finding extreme values. So first thing we're going to do is we need to find the domain of this thing. So these are the notes that you're going to write down with this. Okay, there's certain things you're not allowed to have. You're not allowed to have 0 in the
denominator.
Okay, cannot have 0 in the denominator. What else? Okay, looking at this problem specifically, what can I not have?
A negative.
A negative inside
the radical.
Can't have negative inside the radical, right? Okay, so I am going to do this by finding the domain first, because it's not going to exist outside. So I'm going to use those two things, and I'm going to say that square root of 9 minus x squared is equal to 0. Because if that equals to 0, the whole thing is undefined, right? Yes. But it could be less than 0, can't it? Oh, I'm sorry, not less than 0, more than 0. It could be more than 0, but I'm also going to have other restrictions on this. Okay, so I can't have negatives inside there, but I could have a 0, but I can't have 0 in the denominator. So there's two different things that we're doing here. So we're starting off with this. How do I undo a square root? Square. So square both sides. So I get 9 minus x squared equals 0. Plus x squared to both sides. 9 equals x squared, and square root both sides. X equals plus or minus square root of 9. X equals plus or minus 3. So now, speaking about this in terms of everything here. So, reading through this, if x is equal to positive 3, what happens?
Probably 0.
This is 0, right? But can I have 0 in the denominator? No, I cannot, right? I cannot have 0 in the denominator. Okay? If x is equal to negative 3,
0.
I get a 0 again, okay? Where I would have x being 0 in the denominator, right? The whole thing being 0 in the denominator. So those are two things I cannot have. But what if it was 4? What would happen if I use 4? 4 squared is?
16.
What's 9 minus 16?
7.
Negative 7. Can I have negative 7? Yeah. Okay. So what I'm going to do is I'm going to start by doing a number line here so we could see specifically what it is we're talking about. So we have a negative 3 and we have a positive 3. So you said negative 4, I can't use negative 4, and I can't use positive 4, right? So I can't use anything outside of there. So I can't use those. I can't use that. Yes? Does that make sense?
Mm-hmm.
So this is me testing on a number line for my domain. Can my x equal 3? No, because if my x equals 3, this gives me 0. I cannot have 0 in the denominator. So that means that this, it's going to approach 3, but cannot equal 3. So what symbol should I use here at 3? Yep.
Wait, a symbol?
Yeah, there's a symbol. Parentheses, very good. So it's a parentheses because we're talking about domain. If it was a bracket, that would be equal to. So now it is a parentheses here and a parentheses here. So the domain is from here to here. So we did a couple things together. So we found out values for 0, and 0 is undefined, and I have to have in there, it's got to be greater than, but it can't be too much greater than. So I have a limited window here. So now my domain for this problem is from -3 to +3. So that means if I were to graph this, these would be open circles, open dots on my graph. Now the next thing we're going to do is we are going to take the derivative of this. We're going to take the derivative of this. So I'm going to leave this here. I'm going to go to the next page, and I'm going to rewrite it. And what's my exponent going to be?
1/2.
-1/2. There we go.
Yeah, shifting up.
-1/2. -1/2. So by rewriting it using the exponents versus the radical, the math should be a bit easier. A bit. Now, let's U. So U is 9 minus x squared U prime
-2x.
-2x, very good, -2x. And let's rewrite, so this is going to be U to the -1/2. So my derivative is going to be 1/2 U to the
-3/2.
-3/2 times U prime. All right, let's plug our U's back in and our U prime. 1/2 times minus x squared -3/2 times -2x. Now, I'm going to rewrite it, I'm going to rearrange it, so the negative is going to go back down to the bottom in the denominator. But before we get too far into it, so right here we're going to have a -2 and the 1/2. What's going to happen there? Those are going to cancel. But I still have the negative, right? So what's left on top is going to be x over 9 minus x squared to the 3/2. Now I'm going to rewrite it again back to the radical form just so we could see what this means. X over the square root of 9 minus x squared to the 3rd. Yes, no, maybe? Hopefully.
I thought the 3 would be, because of power over root, I thought the 3 would be right.
It could be outside or it could be inside. It's not going to matter.
I thought it was going to be cube root for a second.
Oh, okay, yeah. So remember, it's 3rd power, so it's power over root. Yeah.
Okay.
All right, restrictions here. So restrictions here. So let's see what happens here now. So from the notes, we know that I'm going to find where f prime of x equals 0. What was that point called? Anyone recall what was the special name?
Stationary point? No.
You said it with a question mark.
No.
You know your notes are in front of you, right?
I think the first word is stationary.
Huh? Yeah, it is a critical point, and I think in this one it is still referred to as stationary point. Nope. Stationary point is, yeah, or f prime is equal to 0.
Oh yeah.
Yeah, these are critical points. So, I was actually looking for critical points, but you said stationary point. I'm like, yeah, that too, but most of the time they just refer to it as just critical.
Point.
Okay, so now we're going to try and find where f prime is equal to 0. So I have my problem. So I take my derivative, which is going to be x over, that's going to be third equals 0. Now I can multiply both sides by the denominator, and what should I end up with? X equals, multiply both sides by the common denominator, right? So multiply by this. Anything times 0 is?
0.
So what are we going to be left with?
0.
X equals?
0.
Because I still have a 0 in the numerator, or an x in the numerator. Does that make sense? Does that not make sense? Did I lose you there? Okay, so like that. Okay, if I multiply both sides by the quantity of 9 minus x squared to 3/2, this side will, right? And then anything times 0? Okay, so the only thing we have left now is x on this side equals 0. Does that make better sense? Or no?
Oh, you're trying to simplify it to keep it as 1x instead of.
Oh, just this one right here? Oh, yeah. So yeah, we're canceling stuff out because I want to try and get this to the point where this is going to work out. So now if we think about it numerically, plug in 0. 0 divided by 9 minus 0 squared to the 3/2. So what is the square root of 9? Because 0 is going to go away, right? Square root of 9 is 3, right? Remember, root is on the bottom, so square root of 9 is 3. And then take that to the third power. It's 27. So it's 0 over 27 if I were to plug in that number. So I end up, in the end, just being 0. So that makes this a true statement of x is 0. Numerically, did that help? Okay. Sometimes I have to do that myself. So does it really make sense? Plug in the number that you have for x to see if that actually makes it true. And by doing that. And also, since we have calculator access now for all our stuff, yeah, you could just plug it into the calculator, see where it happens. A little bit better? Okay. So we have x equals 0. So we don't have anything else. X equals 0. Now I need to go back to my rules, which I'm going way over here. This is the previous problem from yesterday. So endpoints, but am I plugging in the endpoints here? This is yesterday's problem. Okay, this is,
An endpoint. Well,
these are included, aren't they?
yeah, because bracket.
Very good, okay. Now let's back up a little bit to I thought there was one with opens. Okay, so here it is. Yeah, here it is. CB, interior point of the domain of the function, then f of c is a local maximum value at c if and only if it is greater than the values for all x in some interval containing c. This is the open interval. Okay? So, because we cannot be equal to -3 and +3, we can't plug in those two numbers. That's open. Again, local is also another open interval. And function has a maximum local maximum, local minimum at an endpoint C if the appropriate inequality holds for all x in some half open domain interval containing C. So a half open would mean that the endpoint is included. But right now we cannot include the endpoints because we have -3, which is a parentheses, and we have +3, which is also parentheses. So this is open. It's all open. So I don't have to test the endpoints for a minimum or maximum. So this is only going to be a local over this, depending on what we have. So we have critical points. So we only have to test for our critical points. So we know that those ones aren't going to work. So let me go, bam, bam. And I'm going to show you a neat thing with the calculator now. So I know you guys got your calculators out, because that's what good students do, right?
And it's definitely not dead.
Okay. Tater Tot, you need to start cleaning up your mess too, because kid came in yesterday. There was like all kinds of food all over. He's all, why is this always gross? I'm like, oh, sorry. Yeah, I had to apologize to him for you. Anyway, so this is what you're gonna do. I'm gonna show you this neat trick, and we're gonna take this, and if your calculator was dead, what should you do with your calculator? Yeah, good job. I'm gonna control divide is gonna set up my fraction, and I'm gonna enter the original function, which is 1 over square root of 9 minus x square here. There you go. 9 minus x squared. So I graphed it now.
Still a year.
All right, do you guys have the graph? Yes? Okay. Danny? Did you graph it? Okay. So I'm gonna exit this by just hitting scratchpad one more time. Actually, before we do that, let's look. So the critical point of 0, what do you think the critical point of 0 is gonna be? Is it gonna be a minimum or maximum? Looking at the graph, what do you think? at 0, what do you think? Minimum, maximum?
Is it in the middle?
It's in the middle, so it would be a minimum here, right? Because it's coming down, isn't it? So let's go through and test. So I'm going to go out one more time. And this button right here next to delete is called vars, V-A-R. We entered our function in F1. And so of that function, I want to know what -3 gives me. Undefined. It's almost like we just did the math to make sure we found out that -3 was undefined. Now let's do it again. Vars, what was my next critical point? 3. Okay, let's try 3. Also undefined, right? Next one.
0?
Yep, my last one is 0. I get 1/3. So my critical point is going to give me a value of 1/3, but since these two here were undefined, I can't really tell if that's going to be the max or the min if I'm not looking at a graph. So what you could do is we could approach +3. If I approach +3, I just pick a number close to 3. So let's go 2.999. Because it can't be equal to 3, but it could be close. And we could do the same thing for the -3, -2.999. So they both give me this. So now, if at the end point it's coming up here, it's larger than the other points, that makes this one here it's a minimum. Yep, this one's going to be a minimum here. Alrighty, so hopefully that's going to be helpful. Any other questions from that or no? So if you want to try some more problems on your own, you can, but here's a couple different examples that you're going to see on the homework anyway. But other than that, I'm going to have you people work on the next homework, the 4-1.
My lab?
Yep, my lab.
Oh.
There we go. Make sure you all like, share, and subscribe. Hit that notification button. Support my channel.